Hello everyone, welcome to our MOOC on cartographic techniques. So in today's practical session, we will explore about Taylor and Foster method of climographs. So a really neat combination of climate data can be represented using the climographs. It will be simple and ready to use and easy to use graphs will be created in today's sessions. So to begin with, we will start with the introduction on climographs. Then we will move on to understanding the climographic elements. Then I will guide you step by step in creating the climographs. Once the climograph is ready, we will try to interpret that and we will gather what the data tell us. We also have applications of climographs, and in the final we will wrap all the key takeaways. So, to begin with the introduction to climographs, the base for creating any type of climographs or any climo diagrams, it is very important to have the data. So, for that climate data are available in the meteorological department. There are two main factors that are included in the climate data. The first one is past weather condition and the long term averages. So, these are the two factors we gather from the climate data to represent that in a graphical or diagram way. So, there are standard 5 types of diagrams used in cartography to represent the climate data. So, the first one is climograph, then hydrograph, then ergograph, then windrows and star diagrams. So, what are climographs? Climographs are nothing but that represents both temperature and rainfall together over a period of time, usually for the months of the year. Next is the hydrograph. Hydrograph helps us to plot the temperature against humidity to study their relationship. Then ergograph. Ergograph is nothing but it displays the same temperature and rainfall, but in a curves so that it highlights the seasonal variations. Then comes the windrows and star diagram. So, wind and star diagram usually explains about the speed and direction of the wind, and this helps us to understand the behavior of the wind. So, basically what is a climograph? As I mentioned earlier, there are certain elements in climate data. So, all those elements of climates are visually represented in climographs. So, in climograph we will be looking into the elements of climate data. So, these data will be represented using the elements of climate. So, next point is shape and position of the climograph. This is nothing but each shape of a climograph explains us about the climatic condition prevailing in a particular region. So, going into the elements of climatic data, we have temperature, pressure, wind, precipitation and humidity. So, temperature, as we all know, it helps us to plot the difference in temperature in a particular region, whether it is hot or cold. Then we have pressure data. Pressure data we usually uses to understand the high and low pressure. For example, if there is a high pressure, we will be able to know that the skies are clear. Then if it is a low pressure data, then we will be able to understand that there will be a possibility of storms in that particular region. Then comes the wind. Wind data helps us to understand the direction of the wind and from which region to which region it is flowing. Next comes the precipitation. So, precipitations are of different types, as we know, rain, snow, sleet, etc. So, in this session, practical session, we will only look into the rainfall data. So, in precipitation, the rainfall is calculated based on the rainfall gauge stations. So, rainfall is usually calculated using the gauges. Then comes the humidity. Humidity is nothing but the water content present in the air mass. So, it plays a vital role in the formation, weather formation and agricultural activities. Now, coming into the timeline of Climograph, we have various professors and various geographers who put forwarded the different versions of Climographs. First, it was in 1910 by J. Ball, who created the climate data into a visual representation, into a climograph. So, later it was in the year 1926 that John B. Lilly, who expanded the J. Ball's climograph. So, John B. Lilly's climograph is nothing but 12-sided polygon which represents two climatic data or say two climatic variables. Then it was in the year 1940 E. Foster who created climographs based on the factors which we will be looking into later. Then after 1940, soon after that, the US Department of Agriculture, they also explained and they also tried to bring out the climograph to present the agricultural processes and agricultural planning. Next, it was in the final 1949 by Griffith Taylor who created the climograph that is now known as Taylor's method of climograph. And in this session, we will look into the E. Foster and G. Taylor's climograph. So, to begin with the Griffith Taylor's climograph, he created this graph in the year 1949. So, as I mentioned earlier, according to him, climograph or climogram is nothing but the short form of climatological diagrams. So, as I mentioned, his graph is a 12-sided polygon closed one which represents two selected climatic elements. For example, rainfall and temperature or humidity and temperature, like that, in that way. So, he used two climatic variables. The first one is wet bulb temperature and then he used relative humidity against it. So, these two are the main factors that helped him to understand the suitable location for the human population. Next, we will see what is wet bulb temperature. Wet bulb temperature is nothing but the lowest temperature that air can be cooled to by the evaporation of water at a constant pressure. Next, wet bulb temperature is very much important because it is a combination of two factors, that is temperature and humidity. So, it is very much useful for Taylor to understand the exact climate condition prevailing in a particular region. So, most of the field which uses this wet bulb temperature data for their research or for their explorations are meteorology, agriculture, heat stress studies and then relative humidity. Relative humidity is nothing but the percentage of water vapor present in the air to compare to the maximum amount of air that can hold at a temperature. So, these data are also used in various fields like to weather forecasting, agriculture, comfort study and climate analysis. So, next, the main reason why Taylor created this climograph was to understand and to provide a suitable location for the white settler. So, since it was created during that time, It was mainly used for the white settlers, that too in tropical areas. So, apart from to understand the settlement of the white settlers, it was also used by Köppen. So, we all know Köppen is very much familiar for creating the climate classification. So, he was the one who used the Taylor's Climograph method. And here you can see Fahrenheit and degree Celsius. It is nothing but this is the main two factors that he used to represent the temperature in his graph, either in Fahrenheit or in degree Celsius. Then he coined four special terminologies. These are the terminologies which is mainly used in his graph. So, these four terminologies are mainly used to represent each direction of the graph. For example, southeast, northeast, northwest and southwest. So, coming to the factors, raw. Raw defines the cold and moist condition. Then muggy represents hot and dry condition. Simultaneously, scorching also represents hot and dry conditions. Then keen. Keen represents cold and dry conditions. So, these are nothing but the four corners of the graph which the Taylor derived. We will look into a detailed way of scorching, muggy, keen and raw. So, scorching according to Taylor are the regions which experiences the wet bulb temperature over 60 degree Fahrenheit, that is nothing but the 15.5 degree Celsius, and where the relative humidity will be below 40%, and those regions are known as hot and dry climate. Next, coming to the muggy, these are the regions where wet bulb temperature recorded should be 60 degree Fahrenheit, that is 15.5 degree Celsius as I mentioned earlier, and relative humidity over 70%, and these regions are basically considered to be hot and dry climate. Then coming to the keen. Keen are regions which records the wet bulb temperature over 40 degree Fahrenheit, that is nothing but 4.4 degree Celsius, and the relative humidity below 40%. So, these regions are known to be cold and dry climate. Next, coming to the raw, the last corner of the graph explains that regions which are recording the wet bulb temperature over 40 degree Fahrenheit, that is 4.4 degree Celsius, and relative humidity below 70%. So, earlier in keen we saw it is below 40%, and here it is below 70%. So, these regions are known as cold and moist climate. So, here in the diagram you can see the four corners of the terminologies or the zones which was classified by Taylor. So, scorching, muggy, keen and raw. This is the framework created by Taylor to represent in his graph. Apart from the four terminologies, he also explains about the scale of discomfort. Scale of discomfort is nothing but the level of human comfort level. So, here you can see 40 to 45 degree Fahrenheit is considered to be very rarely uncomfortable. So, regions which are recording this between this value will be considered to be very rarely uncomfortable. Then comes 45 degree to 55 degree Fahrenheit. So, it is considered to be the ideal place or ideal comfort level of humans. Then 55 to 60 degree Fahrenheit is really considered as rarely uncomfortable. Then 60 to 65 degree Fahrenheit is considered as sometimes uncomfortable. Then 65 to 70 degree Fahrenheit is considered to be often uncomfortable, and regions which are recorded as above 70 degree Fahrenheit is considered to be usually uncomfortable. So, Taylor derived this for understanding the comfort level of people in different climatic region. Even though we get the temperature or humidity data, it is very important to study the comfort level of human beings. So, we will go into the creating of Taylor's climograph. Before going into the creation of Taylor's climograph, we will look into the basic objective. As I early mentioned, you can see a single graph of him will represent the region's temperature and humidity over a year. Then, this climograph of Taylor will explain us about the trend between the climate data. And then, it also gives us the knowledge of climate patterns to understand the change over the climate variables. Now, we will look into the step to create what are the basic steps that is needed to create a climograph. So, in the beginning, as I told you, there are 4 corners of climatic zones. You can see here scorching, muggy, keen and raw. So, the first step here explains that plotting the relative humidity on the x axis. So, on the x axis you will be plotting the relative humidity. Then on the y axis you will be plotting the wet bulb temperature. So, you need to keep in mind the scale of the graph. So, as I mentioned here, 1 centimeter represents 10% of humidity, and the scale 1 centimeter represents the 10 degree Fahrenheit for the wet bulb temperature. So, before plotting the points, we need to create the framework for the graph. We need to consciously check whether we have marked and plotted correctly the values, x axis and y axis for relative and wet bulb temperature, and the 4 distinct corners of scorching, muggy, keen and raw. So, after plotting and creating the framework, we need to plot the values. So, here I have given the data for Kunnur station in Tamil Nadu. So, here you can see J, F, M, all these are nothing but the short form of your months January, February, March and so on. So, here we have the wet bulb temperature and humidity, wet bulb temperature in degree Fahrenheit and humidity in percentage. So, we will try to plot these values into the graph. For example, here you can see wet bulb temperature shows 31 degree Fahrenheit and humidity shows 68%. So, now we are going to plot this value in the graph. So, here you can see here is the 30. So, 31 is the value, 68 for relative humidity. So, approximately you can plot the value here. Simultaneously for February 32 and 70. So, 32 approximately lies here and 72 here. So, as we step by step we locate the points of the station, we need to join the lines sequentially. So, after joining the 12 points, in the end you will be left with December and January, which is not even complete. So, in that case you have to join the December value and January value together. So, in that way your shape will be completed. It is very important to know about the shape in a climograph. So, coming to the shape of climograph, there are 4 main shapes that are used in climographs of Taylor. The first one is elongated one, then circular, elliptical and spindle. So, elongated one is nothing but your graph will somewhat look like this after plotting each values, for example, January, February, March, like that. Circular will be not the perfect circular shape that we use, but it is like somewhat the semicircle, open circle form. for example, you have your January and December. So, finally, you will join this or say like this. So, it's not a complete closed circular shape, it is a semicircle. Then elliptical in this graph will not be the perfect elliptical shape, but it will look somewhat like this. So, imagine this is your January and December, you will join together. So, somewhat it looks like this. Spindle is the most common shape that we get when we plot the values in the climograph of Taylor. For example, the shape somewhat looks like this. It is an example, so somewhat it looks like this. So, why I have highlighted the shape spindle is because most of the graph will be generated with this spindle shape. So, finally, after plotting all the values which we had from the Coonoor station, we will somewhat get the shape like this, the spindle shape. And for your reference, I have also marked another station's data also. So, it looks like this. So, after plotting everything, you must check whether you have joined all the months. So, as I mentioned, a spindle shape, what does it say? It says about the dry continental climate. Next, a climograph oriented diagonally in the northeast and southwest direction indicates that that region has monsoon type of climate. Similarly, a diagonal climate, that is northwest to southeast direction, represents the Mediterranean climate. So, with this the Taylor's climograph is over. Next we will move on to E. Foster's climograph. So, E. Foster's climograph was developed in the year, as we already saw. Here the derived climograph was the base from Thornthwaite's scheme of climate classification. So, he took the climate classification explained by Thornthwaite. Then it consists of charts that is formed by grid system in a rectangular coordinates. So, if you see the Taylor's graph, it will be similar to the Foster. So, these are two combinations of graph. They try to show us the possible way to represent different climate data or different climate variables in one single graph, so that it will be very useful for us to know about the current or the past climate conditions prevailing in a particular region. So, next his graph has a horizontal bottom scale. So, basically if we are drawing a graph, our graph will start from 0 to say for example 100, but in Foster's climograph we can see his graph starts from 0.18 inches of rainfall and vertical scale indicates starts from minus 20 degree Fahrenheit to 100 degree Fahrenheit. So, this is the basic scale he uses in his climograph. Next, like the Taylor, like how he mentioned scorching, muggy, keen and raw, he also divided the climate zones into frigid, cold, cool, mild, warm and hot. So, according to Foster, the regions which is experiencing minus 20 degree Fahrenheit to 0 degree Fahrenheit will be considered as frigid zone. Then cold regions are categorized into the regions which experiences 0 degree Fahrenheit to 32 degree Fahrenheit, and cool regions are said to be starting from 32 to 50 degree Fahrenheit, and mild zones will be recording 50 degree to 65 degree Fahrenheit, and warm will be ranging from 65 degree to 80 degree Fahrenheit, and hot will be over 80 degree Fahrenheit. So, apart from these zones, these are the standard range of scale he fixed for his climograph. So, apart from this, he further divided cool, mild, warm and hot zones into subdivisions, that is arid, semi-arid, semi-humid and humid. So, here in a tabulated form I have shown you the classification of the zones. Here I have mentioned the climate zone, then limiting temperature start point. So, this is the start point for the limiting temperature and the suitable rainfall in inches. Then you have limiting temperature end point as well and their rainfall in inches. So, if you see the starting limiting point for a zone is 32.4 for everything and limiting temperature end point for this will be 83.2 degree Fahrenheit. So, this is the basic framework for the Foster's Climograph. So, this was published in a book named Maps and Diagram by F.J. Monkhouse and H.R. Williamson. So, as I mentioned, you can see the limiting start point and end point, and you can see the subdivision of hot, mild and cool, arid, semi-arid, semi-humid and humid. So, you can see the values are starting from minus 20 to 80 or say 100 and 0 to 18 for precipitation. Then the main objective, as we saw for the Taylor, this also have some main objective since it is not further used in that much, but it also has some common objective. So, in that way we can say it is helpful to classify and communicate the climate information for a specific region. Then we can quickly describe the location's climate. So, in creating the climograph of Foster, we will look into few datas how to plot the values. For example, here you have January, the rainfall is 12 inches and temperature is in 32 degree Fahrenheit. So, for example, rainfall in 12 and temperature in 32. So, this region can be located as January. So, you can perfectly plot the values. For example, I am just showing. So, simultaneously you can plot February, March, April and finally, like how we did for the Taylor's climograph, we can join all the values. So, here I will be showing you the completed version of the climograph of Foster. So, here when we interpret, we know that this region is cool and humid throughout the year and there is no extreme dry seasons and there is a mild summer increase in temperature and rainfall. And also it shows that around 8 inches in the driest month and about 14 to 15 inches in the wettest month. So, this is the final map which you will be creating with the help of Foster's climograph zones. Next, we have few applications of climographs. For example, the applications are wide in many fields, but we are going to look into the major field which uses the climograph. Meteorological department, as we all know, agriculture and environment. So, all these are mainly used to understand the seasonal variation in temperature, and in agriculture if you see, it is used to plan the irrigation, and in environmental science to assess the habitat and stability and monitor the ecosystem changes. Simultaneously, in urban and regional planning, you can see to design the climate responsive building and to plan water and green space management. Then comes the tourism and recreation. So, in tourism they use the climographs mainly for identifying the best seasonal places and to plan the seasonal activities. Then comes the public health. public health also uses Climograph for various purposes. The main thing is to assess the heat stress and comfort level. And they also use the Climograph to understand the risk that comes from the climate. So, these are some of the key takeaways we are going to see now. So, first we understood what is Climograph and what is the role in representing the climate data. Then we learned about Taylor and Foster method and how they combined the temperature and the precipitation into a simple single graph. Then we understood the concept of scale of discomfort. Then we try to interpret the climate pattern from the Climograph which we created. Then we also developed a skill to compare the climates of different regions. And finally, we saw a few applications of Climographs where it is widely used. So, this is for today about Taylor and Foster method of Climograph. It not only helped us to understand the Climograph, but it also helped us to create, interpret and use them in real life. Thank you.